Welcome to Module 1. This is the first session of 8. By the time we finish today, I promise you will look at every machine around you differently. We will not be touching a single robot today, but we're going to start somewhere much more interesting, your mind. Before we talk about sensors or controllers or actuators, I want to ask you one question. What machines do you see around you every day? Think about how you left your house this morning, your kitchen, your street, your school, your classroom, your compound, the grinding machine at the market, the generator behind your fence, the borehole pump in the yard, the ATM at the bank, even the traffic light at the junction. Keep all of these in mind. We're going to return to every single one of them because each one is hiding the same simple pattern, and once you see it, you will never stop seeing it. When most people hear the word robot, this is what they picture. Something shiny, something metal, something that walks and talks, something from a movie, something from abroad, something expensive, something that absolutely does not belong in a classroom in your state. That image is a stereotype. It is the single biggest thing standing between your learners and robotics education. A robot is not that. A robot is something you have been using your entire life, and I'm going to show you exactly what I mean. So here is the definition. This is the one sentence that everything we do in this program rests on. It uses what it receives to decide what to do next. Now let's recap. Pause and read what you see on the screen. The traffic light is just the beginning. Every machine on this grid is in your neighborhood right now, and every one of them is a robot. The borehole pump. Input. Someone turns the switch. Process. The motor drives the pump. Output. Water. The grinding machine. Input. Grains are fed in. Process. Blades crush. Output. Paste. Now it's your turn to draw an IPO model. I need you to look at the list on the screen. We have talked about the borehole pump and the grinding machine. I need you to choose one machine from the remaining 4 machines that are left. On your piece of paper, draw 3 blank boxes and write the IPO model for the machine you have selected. Don't forget input, process, and output. I repeat, choose one machine from the list on the screen, draw 3 blank boxes, and write out the IPO model for the machine you have selected. Now let us give every part of that system its proper name. The sensor, that is the input part, which receives information from the world, what the robot sees, hears, touches, or measures. Without a sensor, the robot is blind. The controller, that is the process part, the brain. It receives the sensor's information and makes a decision. Every program we write lives here. The motor or actuator, this is the output part. It turns the controller's decision into physical action. The wheel spins, an arm moves, a pump activates, and the power supply. If you could design a robot to solve one problem in your community, what would it do? Pick up your pen and your paper. Draw this robot. Don't forget that the drawing is not the point, so the drawing does not have to be pretty. Draw your robot. Think about the problem in the community you want to solve. For example, the robot can monitor water level in your house or your school. The robot can tell people when it wants to rain or when there's a storm coming. Or the robot can tell a farmer that the crops are dry and he needs water.
Something that simple, okay? The point here is for you to be able to label the three things: what your robot senses, what your robot decides, and what your robot does. Don't forget, when you're done, carry out this activity with your learners and swap your sheets. Then label the input, the process, and the output. Every robot you draw has some IPO logic in it.